how can a farmer look at their property and determine the state or health of their property? Let's assume we're a pasture grazier of some sort, or a dairy farmer, or a sheep or goat or whatever. We walk out, and are we seeing bare patches? Are there bare patches where there should be pasture? Are there weeds, what we call weedy species, when there should be pasture? When we've had a dry spell, how quickly does my grass dry off? How much pasture can I hold on to? Am I running too many stock? Should I be thinking about manipulating my herd? Are my paddocks too big? Am I not rotating my stock often enough? Am I eating down too much, having my stock eat down too much grass, so I'm not getting good recovery and good photosynthesis? All of these things are signs that maybe something is going wrong. The other thing too is, if there are bare patches, and if you are on a slope, when you get rain, is your soil absorbing the rain? Are you taking in 100% of the water that's being offered to you by nature? If you're not, it's going to be running off. It's going to be causing furrows. It's going to be causing problems with your waterways. All of these things, as a farmer, you can stand there and you can say, yeah, there's something wrong, because I can't tick off these things as not happening. These are happening on my farm, some or all. Therefore, where do I go next? If you're going to start the journey from or changing the paradigm, for example, from conventional, what I call industrial farming, into a biological and a more benign and more environmentally friendly sort of regenerative agriculture paradigm, then it's important to know what you're starting with. It's important to know what your baseline is. And so, for example, I as an analogy, you don't go and get a whole bundle of antibiotics unless you've been to the doctor to tell you that what is wrong so you can get the right antibiotics. You don't go to a car salesman and buy a car when you can see there's obviously a problem. You haven't asked the question about what is wrong with this car. It's the same thing with the soil. If you're in conventional agriculture, you don't go and apply a whole lot of NPK until the agronomist has said, oh, we need a chemistry. The same thing is with if you're going to go into a biological system. What I ask when my clients start with me, I say, we need to know what the biology is doing, given that this farm has had a history of potential damage to the microbiology. We need a soil test that's taken across the property to tell us what biology is there, what ones are missing, what ones we need to deal with, and help. And the other thing we need is not just a chemistry that the agronomist is asking for. We're wanting a chemistry that has the soluble pool, the exchangeable pool, but what's really important is what is locked up in the total pool. Because when synthetic chemistry is put on, very little of it is actually used by the plants. Most of it is locked up, it's volatilized, or it's leached away. But that is locked up in that total pool is not accessible to the plants. It's not plant available. It's not accessible. But even worse than that, it's there because it's not accessible by the microbiology either. So we need to know what's in that total pool. So for about $500, you can get a full biology and a full chemistry that gives you the baseline of what you're going to start with when you want to start on the journey to biological farming. And so what you're doing is what you would do, as I say, when you're in a conventional farming situation. You find out what you haven't got, and then you add it. Thing without, but we want to look at the biology as well. And once we've got that, then we can say, okay, we know what we've got locked up. We know what biology is missing. We know how to go about accessing often thousands of years, hundreds of years of locked up chemical that you've been applying, you've paid for, but you can't use. Yeah, as a scientist or as a biologist, I kind of like to think of myself as a biologist. So what we do is the soil comes in, and we first of all have a look at the structure. Does it have any structure? We have a look with smell. We have a look at color. And then we start to break it down into the various tests that we're going to do. If we're going to look for nematodes or earthworms, or our other various tests, then we start to break it down and do dilutions, etc. But the first thing we look at is the texture, the structure, because that will tell us initially just how that soil has been handled up to when it's come to us. When we look at soil, if we see a soil that is very dry, it's usually in clumps. The aggregates are very hard, very stony, very very hard to break apart. In those sorts of soils, we realize that, and we see that there are very few roots to the plants. The plant roots are very shallow. So what this is saying to us is either this soil has come from a drought, and we know what the weather patterns are because we always look on the Met Bureau. So we know this hasn't come from a particularly long dry period. So therefore, the texture of the soil tells us that there's something wrong. It's not being held together. It hasn't got a good lot of organic matter in it that's allowing the plant roots to go down and sort of form that biological biomass that helps us to hold water. So that initially is one. The other one at the other extreme is if we see a soil that is really, really wet and goopy and smelly, it's anaerobic. And so this means that there's not good drainage. There's a problem with the drainage. So just by putting a spade into the ground and digging out a spade depth of soil, the farmer can have a look and say, oh gosh, there's water coming up. Therefore, there's a drainage problem. Or it's breaking apart. I can't get the spade of soil out. And now I've got the spade of soil out. There's no earthworms. The roots aren't going down into that spade depth. There's a problem here with this soil.